So welcome. In this lecture, we are going to study about increasing and decreasing functions. So we'll start by defining. So function f is increasing on an interval if for every two or for any two numbers x1 and x2 in the interval x1 less than x2 implies f of x1 is less than f of x2. And then similarly, a function f is decreasing on an interval if for any two numbers x1 and x2 in the interval x1 less than x2 implies f of x1 is greater than f of x2. So for a layman, from layman's point of view, we can say a function is increasing if as x moves to the right, its graph moves up and is decreasing if its graph moves down. So let's draw a sketch to illustrate that. So we have so for this case here, this is x equals to a, this x equals to b, this is the function. So this is increasing, and in this other limb, decreasing. So here is constant. And then this is A, this is B. So here f prime of x is less than 0. Here f of x is 0. Here f prime of x is greater than 0. So we can also say, we can also understand the same things by saying so this theorem, so the sign of the derivative so let f be a differentiable function on an interval, an open interval, AB. So point 1, if f prime of x is greater than 0 for all x in this open interval AB, then f is increasing on AB. And then number 2, if f prime of x is strictly less than 0, then f is decreasing on this open interval AB. So that is what you need to know. And then you say the tangent lines have positive slope for increasing functions. So I can draw some sketches here. So if you draw a tangent here, 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 and then another point, tangent lines have negative slope. So this is a negative slope. For decreasing functions. So remember, this is going up, this is going up. Or we have this. So here, draw a tangent here. So going down, going down. That's what we have. And then remember number 3 for this part here, when the for Roman 3, if f prime of x equals to 0 for all x in this open interval, then f is constant on this interval AB. So how to find interval for increasing or decreasing functions. So list them, then next session we do examples 1. So let's give the statement first. So let f be continuous on interval AB to find the open interval on which f is increasing or decreasing. We use the following steps. One, locate all the critical points or critical numbers of f in this open interval AB, and use these numbers to determine test intervals. Number 2, determine the sign of derivative of the function at one test value in each of the intervals. Number 3, use the theorem stated above for knowing just stated above to determine whether f is increasing or decreasing on each interval. Now remember, these guidelines are also valid if the interval is replaced by an interval of the form minus infinity to b, a to infinity, or minus infinity, positive infinity. So this theorem we are referring in example 4 is this part here. So this is what we are not really not this one here. We are referring to this. This theorem is what we are referring to. So this is the theorem we are referring to in step 3. So in the next session, we are going to do examples on determining intervals of increasing or decreasing for function. So thank you.